Emitter follower amplifier. Emitter amplifier. Let's see the circuit. We have got the transistor here. In order to provide the biasing for the transistor, here we have used potential divider biasing or voltage divider biasing. That is, we have connected two resistances R1 and R2 in series to the VCC that is supplied, and we are giving the input to the transistor through a input capacitor. The input signal given to the transistor through a input coupling capacitor Cin. Now, if we compare this circuit with the previous common emitter amplifier, we can see that the output is taken across emitter terminal, collector terminal. So, with the previous circuit diagram, we have taken the output across the collector resistance, which was connected almost here in the collector. So, we had taken the output across this collector resistance in the previous circuit. But in this emitter follower circuit, we are taking the output across the emitter resistance, which is connected at the emitter of the transistor. Now, most important features are this emitter follower circuit with high input impedance, low output impedance, and it is an ideal circuit for impedance matching. Current amplifier circuit with a no voltage gain. So, emitter follower amplifier is a current amplifier which has no voltage gain. Also, we are not taking output across the collector. There is no need of RL to be connected at the collector. So, RL is absent at collector terminal but present at the emitter terminal of the circuit. Amplifier by potential divider method. So in the above circuit, we have used the method. We can also use base resistor method for giving the biasing. Right between base and emitter develops an output VO across RE, and it is given by VO is equal to IE RE. We can say that output applied to the input through feedback. Hence, feedback voltage Vf will be equal to voltage. As we had already told, the emitter follower circuit is basically a current feedback circuit. Why? Because the output voltage developed across the emitter resistance Re will be proportional to the emitter current. Hence, beta will be equal to the ratio of Vf and Vo, and it will be equal to 1. And the input signal voltage, which we represent as Vi, will be equal to the difference of Vs and Vo. What is Vs and Vo? Vo is nothing else but our output voltage, and Vs is our signal voltage. Signal voltage means the signal which we are giving as the input. That is the signal which is meant to be amplified by the circuit. So, here the feedback is negative as we have got the input voltage as the difference of the signal voltage and the output voltage. We say the feedback is negative. So, here emitter follower circuit is a negative feedback circuit and a current feedback circuit. To tell about the major characteristics of emitter follower circuit, it has no voltage gain, or we can say that its voltage gain is nearly equivalent to 1. Why? Because voltage gain, as we know, it is given by the ratio of output voltage to input voltage, that is VO by Vin. And we had already told that the emitter follower circuit gives an output voltage almost equivalent to input voltage. So VO and Vin will be approximately same. Both the numerator and denominator will be almost same. So the ratio will be equal to 1. It has got relatively high current gain as well as high power gain. Now another character is that it has high input impedance and low output impedance. Input and output AC voltages will be in phase. As we have told, the output and input voltages are almost equivalent, so they will also be in phase. Now, to tell about the applications, we use emitter follower circuit for providing current amplification with no voltage gain. And it is another application is also used for another application, that is impedance matching. Getting detail into the application, first we shall see the application to provide current amplification with no voltage gain. So, as we have already told, emitter follower amplifier, it's a current amplifier which has got no voltage gain. That is, the ratio of output voltage to input voltage, VO by Vin is equal to 1. Why? Because Vout will almost be equal to or same as Vin. So the ratio will be equal to 1. That is because of the reason that there is no much increase in the amplitude of output voltage as compared to input voltage. They both of them will almost be same. So the voltage gain is equal to 1. In digital electronics, there are many cases in which current is required to be increased, but no increase in voltage is required. In such situations, we may use emitter follower. In the given figure, it's a two-stage amplifier. So suppose this two-stage amplifier is attaining the desired voltage gain, but current gain is insufficient. So in this case, we may use emitter follower to increase the current gain without any increase in voltage gain. Application is impedance matching. So as we can see in this figure, there is a source whose output impedance is 120 kilo ohm, and we have got a load which has got the impedance as 20 ohm. As we can see, there is a very big difference between these impedances of source and load. This source impedance is in the range of kilo ohms and the load impedance is just in the range of ohms. So instead of connecting the source and load directly, we are connecting the source and load through a buffer circuit, and emitter follower can act as this buffer. As we have seen, emitter follower has got a high input impedance and a low output impedance. So the high output impedance of the source is matching with the high input impedance of the emitter follower, and low impedance of the load is matching with the low output impedance of the emitter follower circuit. So by including this emitter follower circuit as a buffer, the advantage is that maximum power may be transferred from this source to load. If you are connecting the source and load directly without this emitter follower, due to such a very big difference in the impedances of source and load, maximum power cannot be transferred.